Earth's aphelion and perihelion. What is aphelion? What is perihelion? Perihelion is the point in Earth's orbit when it is nearest to the Sun. Aphelion is the point around Earth's orbit when it is furthest from the Sun. So what is the distance of our planet from the Sun when it is at perihelion? What is the distance of our planet from the Sun when it is at aphelion? Those are the questions that we will answer in this video. You are still with Precalculus and we are talking about ellipse here. In particular, the application of eccentricity. So let us read our problem. Example 1.25, eccentricity and the orbit of Earth around the Sun. The orbit of Earth around the Sun is in the shape of an ellipse, with the Sun being one of the foci. The length of the major axis is 297,600,000 kilometers and the eccentricity is 0.0167. Find the largest and least distances of Earth or from the Earth to the Sun. So this is the largest distance would coincide with aphelion, and the least distance would coincide with Earth's perihelion. Now, I want you to pay attention to eccentricity because this was our topic in the last video. This one has an eccentricity of 0.74. This one has an eccentricity of 0.23. When our eccentricity is close to 1, our ellipse is distinctively oval. It's really an ellipse. But when the value of E gets closer to 0, look at what happens. It becomes almost like a perfect circle. And this is the value of the eccentricity of Earth's orbit around the Sun. It is almost like a perfect circle. This is the information that is given. BC, the length of the major axis is this one, 297,600,000 kilometers. Now pay attention that BC is what we call 2A. 2 times A. A is the distance from the center to one endpoint of your major axis. Our E is equal to 0.0167, and from our previous discussion, we laid down how to compute for E. E is equal to C over A. So we shall look for BA, the length of the line segment BA. This will coincide with Earth's aphelion. It is furthest from the Sun when our planet is at its aphelion. What is that distance? BA. We shall look for CA. It's the shortest distance. And when our our planet is nearest to our Sun, Earth is said to be at perihelion. So how are we going to get BA and CA? Okay, so let us pay attention to this. Okay, so from the center to one endpoint of your major axis, that is A, the length is A. From the center to one focus is C. So in order to get BA, we get A plus C. In order to get CA, the nearest distance, that would be A minus C. So we just need to obtain A and C. Okay, so let's do it. A is 1/2 the length of your major axis. I am sorry, this is wrong. This should not be BA, this should be BC. So A is 1/2 the length of your major axis, BC. I apologize. And that is equal to this, 148,800,000 kilometers. How about C? We are not given C in our problem. What we are given is the eccentricity. So we have the value for E and the value for A. Solving for C, C is E times A. So we did the multiplication, and this is the value of C. The value of C is 2,400 No, 2,484,960 kilometers. This is C. This is the distance of the focus, so from an imaginary center in the orbit of our planet around the sun. Okay, so I think we are now prepared to obtain BA and CA. So CA is A minus C. That is equal to this, 146 million kilometers. What is BA? BA is A plus C. That is approximately 151,284,960 kilometers. Put that in your vocabulary. Perihelion and aphelion. In aphelion, our Earth is furthest from the sun. In perihelion, our planet is nearest to the sun.